Okay, so hi everybody. Welcome to our weekly seminar here at the Institute of Astrophysics. Today we have the pleasure to have with us Dr. Stefano Covino. Let me introduce Dr. Covino very briefly. So he studied physics and obtained his PhD in astronomy at the Università degli Studi di Milano. And since 2000, Dr. Covino is a researcher at the Osservatorio Astronomico di Brera, also in Milano. The main scientific interests of Dr. Covino are gamma ray bursts, gamma ray and optical time domain studies of active galactic nuclei, multi-messenger astronomies, and as well as astronomical instrumentation. And forgive me if I forgot something. And today, Dr. Covino, he will talk us about VSTPOL, the first large survey telescope for optical polarimetry. So thanks for accepting our invitation. The floor is yours.
I thank you for the invitation. I'm very happy and proud to be here with you. Yeah, your introduction was more than enough. Okay. First of all, I beg your pardon if my voice could be occasionally feeble because I got a cold a couple of days ago. It's fairly cold in northern Italy these days, and you know, it happens, but I'm fine. And this talk is, I think, somehow unusual. Well, actually unusual. It's the typical talk when you describe a future instrument. So I will essentially never go in detail about the things that I'm going to discuss. I want to show you, to explain to you how this idea was born and how it is going, when the telescope will be operational with the polarimetric mode. And I will describe very briefly a few typical science cases that can be of interest for an instrument like this. Of course, please stop me, interrupt me anytime you have some question, or if you want to have some clarification. And okay, let's go on. So essentially, why we are speaking of a polarimetric add-on for the VST. First of all, for those of you, a few of us maybe that don't know, what is the VST, the telescope? VST stands for VLT Survey Telescope. It's an intermediate size, or maybe today small size telescope, 2.6 meter, designed to carry out surveys at the same site of the VLT. It is this telescope is, well, of course, as any modern telescope, has an active primary mirror. It doesn't have, of course, adaptive optics because it is impossible to do nowadays with the larger field of view and in the optical in particular. Nevertheless, thanks also, of course, to the amazing sight, the optical quality of this telescope is very good. Is very good not only in the center of the field of view, but for the whole field of view. The field of view is a 1 square degree, and of course it was operational for 10 years, roughly, more or less. And you can easily find the results of the typical results of a survey telescope. So surveys devoted to, I think, several different science topics like larger scale structure, even galactic structure, actually studying the dust distribution, the distribution of different kinds of objects, peculiar or not so peculiar objects, and so on. There could be actually many curious stories about this telescope. I will not waste our time for that, but I was a young PhD student when I was told that when people were shipping telescope components to Chile, and disembarking the mirror was broken. And I don't know if in Greece it is the same, but in Italy, when this happens, it's considered a very bad thing for superstitious things. But actually, this did not happen. The telescope had a difficult infancy, but was very successful during the operations. Now, the telescope, well, after the expire of the agreement between ESO and INAF, INAF is the Italian Astrophysical Institute, and the telescope is now owned by INAF, managed by INAF, but of course it's still there. And it'll be offered again to the community as other Italian telescopes, like the Galileo telescope at the Canary Islands, for instance. But there was a debate about what to do with an instrument of this category for the future. 1 square degree is not bad even today, but you know, there are several, and in the future probably many survey telescopes with a field of view of several square degrees, to say the least. Not to mention the giant 8-meter class telescopes that are going to begin operations even in this field. So there was a conference, actually an online conference in Naples, and a small team of people, including myself, of course, proposed to change some piece of hardware to have the possibility to do polarimetry with this telescope, and this is by itself nothing special, although, as you very well know, polarimeters are far from being common in the community, but the idea is to have polarimetry covering, having the possibility to do polarimetry for covering the whole field of view altogether. Why we added this idea? Well, because there were several combinations of opportunities that we tried to take. First of all, the VST is located in Paranal, as you know, and very close to Paranal, to Cerro Paranal, there is the site of the Cherenkov Telescope Array South. For those of you who are not confident with this acronym, CTA is the future is already under development, and they are building it. Main facility for Cherenkov astronomy. There are 2 sites, one in the north that I guess is in La Palma, and one in the south that is close to Paranal. What do we have to share? What do we have to share with the Cherenkov astronomy? Essentially, several years ago, there was I'm part of the MAGIC collaboration, one of the present Cherenkov telescopes. And there was a discussion for the future about the needed follow-up optical facilities, essentially because, please allow me to go quickly for this topic, most of the Cherenkov very high energy astronomy science topics need a multi-wavelength approach. So with just the very high energy photons, often you cannot really address the topics, not always, but often. So there was a discussion about the idea of having telescopes co-pointing in most cases with the array, with the Cherenkov telescopes, providing the multi-wavelength, they needed multi-wavelength information. There was a discussion about the optical photometry, but optical photometry is relatively easy to get. There are many telescopes already now providing almost real-time information for the sources of interest for Cherenkov astronomy. A big question mark was polarimetry. Actually, there are telescopes doing polarimetry for the sources observed by the Cherenkov telescopes, but the idea was to have something in the same site and pointing essentially almost any time it was meaningful with the array. And the idea, it was clear that they needed, if you prefer, a relatively large size telescope, so not as 50, 60 centimeter telescope, with good optical, with good polarimetric capability. This telescope was not available, is not available, that it doesn't exist in the site. But, you know, this idea was circulating, and when there was this meeting that I mentioned before in Naples, we thought that it could be a good idea to upgrade the VST, not only to have a polarimeter good enough, but to have a large field of view polarimeter. So in order to cover an almost, not totally of course, almost new observational window. There are large-scale polarimeters. For instance, I remember a group in South Africa and so on, but they are still, at least so far, using a relatively small size telescope. So that was considered a very attractive opportunity. So what happens? This was just an idea. We proposed this idea to INAF, and as usual, when you speak to financial agency, or actually INAF is more than a financial agency, but you know, when you are asking for, when we are looking for money, the reply was, well, nice idea, maybe in the future. But as we were discussing informally with Carolina a few minutes ago, we also we still have in Italy, the availability of a fair amount of money, at least for science, I mean, that could be used to upgrade infrastructures, not only scientific, or actually mainly not scientific infrastructure, but there was also the possibility to have money for that. And the CTA consortium got a fair amount of money to build some of the units they need. Please allow me not to go in detail, but of course, if you want to ask, I can do. And we propose to use a small part of this money to update this telescope, the VST, to have a polarimetric capability, with the idea to share some of the observing time working as let's say, providing follow-up in almost real time for the CTA. So essentially, we got the needed money rather quickly. The idea was considered a good idea, and here we are. Technically speaking, we do not need to dismantle the telescope and the camera, but it is not even, let's say, it's not just the need to add a new filter, if you like, because in order to cover the whole field of view, you have to change a rather large optomechanical device. You have to rewrite the software and so on. And the idea is, of course, to save the large field of view capability of the VST, and having just the possibility to switch to the polarimetric mode without destroying anything. I'm not the right person to explain to you the technical part, but essentially, after some very rapid actually consideration, it was clear that it could not be feasible using the typical technology that we use in optical polarimeters. I don't know, for instance, Wollaston prisms and so on. It is essentially impossible to have them of the needed size. So we decided to work with one of the probably oldest and simplest polarimeters in the optical. Essentially, we are using a rotating Polaroid filter. This is not really advanced, although it is the only possibility to cover the whole field of view. But exactly because we are observing in a large field of view, this also offers the possibility to calibrate much better than actually what actually it is possible, the results of polarimetric observations with the Polaroid filter. I will mention something at the end, so you can see the expected performances of this telescope. Okay, a few rendering about what the people are doing. They are designing this new part of the telescope, substituting actually one of the old parts, and some of the old parts. And you can see that things are going on. Actually, these is our activities that we are carrying out in 2024. We expect that the telescope will be in commissioning phase in 2026. So in less than two years, actually, from now, the telescope will be operational. Some technical details anyway. The Polaroid foil that we are using are quite advanced. It was not easy to find a firm available to build a Polaroid that large with the requirements that are needed for astronomical observation. And the solution that we got is good, but you know, it's almost blind in the ultraviolet, and this is okay. But also in the red. So essentially the range good for optical polarimetry with the VST will be from the G to the R bands. Already the I bands will be not too efficient, although in principle it is possible. And this is the structure of the project. The principal investigator is Pietro Schipani, who is not by chance, who eventually allowed the VST to be a successful telescope. He is an amazing optical designer. And I serve as a project scientist. Of course, I have always been interested in polarimetry, and there are several other people involved from technology. A special role for the optical design, for the design of the polarimeter, and for the development of a pipeline to allow an almost automatic reduction is due to Franz Snick. And you probably know him, one of the best experts in around for optical polarimetry. Okay. So let's go to science. As I said, I'm not discussing in detail these science cases, but just consider that we have two different requirements. From one side, we have the CTA. The CTA, as all other Cherenkov telescopes, will mainly observe sources like AGN, blazar, or in general, where there is some acceleration. Cosmic accelerators are always sources of interest for very high energy astrophysics, as you can easily guess. In those cases, while in several cases it could also be important to have a large field of view, because the Cherenkov telescope can observe in a relatively large field of view, larger actually than the VST. In several cases, we are just interested in a single target. So using the VST for a single target is not the best use of a telescope like this. But on the other hand, observing more or less simultaneously, actually not more or less, simultaneously with the CTA allows one to have, for instance, time-resolved polarimetry. Since the size of the telescope is large enough for most of the targets of interest of Cherenkov astronomy, this is a very important addition. On the other hand, of course, there are science cases where the large field of view is just mandatory, is the focal point, because there is no real need to compete with a small field of view telescope with a Wollaston prism, for instance, because in most cases their capabilities will be better than the VST. But of course, we can do different kind of sciences in not in competition, but but with a profitable collaboration. Well, okay. Nobody of you needs to be reminded that target of interest of Cherenkov astronomy can also be, and usually they are occasionally also strongly polarized, but in general they are always polarized, and therefore that polarization is of great interest is not a surprise. Now I'm just showing you a few examples that are of interest of the CTA community, that not necessarily these targets, but in general, anytime you have a target that is extended in the sky, it's larger than the few arc mean that you usually have with a narrow field instrument. And when these targets can emit linearly polarized optical light, these targets can be of interest for a telescope like the Cherenkov, like the VST. I just reported structures, objects that have a structure in large on the field of view, just to say that there is a really increasing interest in the CTA community, because there is also the possibility to study, for instance, the Cherenkov emission from different sources in nearby galaxies, or the jet structure in nearby objects, and simultaneously to get some polarimetry, when of course these objects are bright enough for a 2.6 meter polarimeter. Now, as I mentioned before, in all cases, Cherenkov astronomy, in almost all cases, Cherenkov astronomy need multi-wavelength observations. Now we have IXPE, an amazing instrument providing X-ray polarimetry. And occasionally it was possible to have simultaneous monitoring from the present day available Cherenkov facilities like MAGIC or HESS or so, and IXPE, and that allowed them, the involved researchers, to do great science. This is my humble opinion, at least. And you can guess what can be done when you can add time-resolved optical polarimetry for this kind of sources. Like essentially you have data not just 1 point per day, as it happens now, or a few points per day, but almost having almost the capability to get polarimetric measurements with a time scale that is not too different compared to the time scale of the flux variation in the very high energy regime. I can mention, for instance, what actually we did many years ago with the TNG. The Galileo telescope is larger than the VST, but essentially I was at the time PI of a small polarimetric facility that was added to the telescope in the optical. It was called Paolo. Now it is dismantled. It is no more available. And we tried, just for testing the instrument, to observe bright AGN or blazars like VLT, for instance, the prototype. And it was very, in spite of the fact that we didn't get amazingly unexpected results, it was very interesting to see how good was the physics possible to address with a time-resolved analysis of these sources that are usually variable on very short time scales. In that case, we had time-resolved analysis in polarimetry with less than 1 minute time scale. It is even too much, but you know, if you can get data every 5 minutes or so, you can do very interesting things. I was discussing about AGN and blazars because at least 50% of the time the CTA will observe this kind of targets. But please do not forget that there are also transients and gamma ray bursts in particular, but not only, that are of interest of Cherenkov astronomy. And again, having the possibility to observe immediately, even when you do not have yet clearly identified the transient in the optical, if any, because you're just observing the field. With a large field of view, polarimeter can be of interest. These are just examples of data obtained with a very famous gamma ray burst that was also observed with magic in a very high energy. This is another case. Now we have also X-ray observations also, although we only have upper limits. But just to say, I think I do not need to convince you that polarimetry, optical polarimetry of transient sources when they are bright enough is of great importance. And speaking of gamma ray burst, of course, here we have a problem. Apart from very few cases of great interest, but very few, gamma ray burst afterglows are bright, but not very bright. In most cases, it won't be possible to do polarimetry with a 2.6 meter telescope. At least if we refer to the late afterglow, where late means later than a few hours. This plot, actually very old, show the typical polarization, linear polarization level from optical afterglows that is of the order of 1, 2, 3%. There was also this quite peculiar and still not understood case with 10% that could be much easier, but it was the only one case in more than 25 years of observations. So this with this polarization degree and with the typical magnitudes of a late time afterglow that can go from, I mean, after a few hours, R18 to R20, this is not feasible for the VST. Things can be different if we go to the very early afterglow, where very early means minutes after the event. And there are two reasons. Of course, at the very beginning, the afterglows can be fairly bright, brighter than, I don't know, 15, 16 or so. And they can also be highly polarized. Highly, I mean, in terms of astrophysical sources. For instance, this specific case was around 15% polarization. That makes things much easier, as you know. So the idea is if you can go rapidly to the field of view delivered by high energy satellite, even if you don't know the optical counterpart, you don't care, you begin to know the field. If the optical counterpart is detected and if the optical counterpart is bright enough, you can have important, solid polarimetric observations. This is one of the ideas, of course. In order to do that, we had to change the software driving the VST, because since it was designed as a survey telescope, it was not designed for the rapid response mode at ESO. You know what the rapid response mode is. Essentially, you can drive one of the VLT units and automatically, almost automatically, the telescope will go to the new target and begin acquisition. This can be done even for the VST in 5, 6 minutes or something like that, 7 minutes. So not bad, I think. It is worth a shot, let's say. Let's go on. The same idea, of course, we are now mentioning something very demanding, could be done for any transient where you know the position better than 1 square degree, but you don't know if there is an optical counterpart. And in particular, this could be useful for counterparts of gravitational wave. Now, I know what you are thinking, and I also think that we have just one case 5 years ago, amazing, extraordinary, whatever you want, but just one case in 5 years. What can I say? If it happens again, having the possibility to do polarimetry quickly before the target is identified, of course, I'm referring to the future advancement of the gravitational wave detectors, when we hope there will be the possibility to have uncertainties and not too large, several square degrees or so. and this is feasible. Well, in that case, you can have early time polarimetry, exactly when we do expect, according to the available models, to have something very interesting to observe. There are where you know that there have been late time polarimetric observations of the counterpart of the 2017 GFO kilonova, carried out by my team. We got nothing, I mean, upper limits that are of interest, of course, given that it is a new source, but this is definitely well beyond any capability, the capability of a telescope like the VST, but at early times, it can be different. Okay, let's go on. Going just mentioning some of the most interesting, probably, science cases when the larger field of view becomes mandatory and important. One interesting point is to study the 3D galactic magnetic field structure. Essentially, the idea is to observe stars. They are, as you well know, usually not polarized intrinsically, apart from peculiar cases. And due to the dust, they can be polarized. And this polarization, the position angle, depends on the amount of dust and the alignment of dust grains that are typically not fully spherical with the galactic magnetic field. This is done already, but you can guess what can be done with a 2.5, 2.6 meter telescope on a 1 square degree field of view. And you can, of course, connect this kind of observations with what we know already from surveys of the dust distribution in the galaxy and so on. Another quite interesting topic, I'm not confident with that at all, but I was told it's of interest, but I believe, of course, is to study the position angle of many AGN. They can be polarized, they are usually polarized. There are so many targets that a large fraction of them is of interest for a 2.6 meter telescope. And with a large field of view, you can observe many of them. And you can do statistics because there is still some of you have already worked on has been working in this field in the past. There is a longer lasting discussion about the possibility that this orientation is not random actually, and this can be a very intriguing topic to study. Even minor bodies of the solar system are of interest. Again, this is nothing new. Polarimetry of asteroids is done since ever, but choosing in a clever way the fields, you can observe many asteroids all at once, and you have a dramatic increase of the amount of information that you have on these targets, in particular if you can do some sort of time resolved observation, or better, you can try to follow the rotation of these objects. And comets are typically targets that are a nightmare for any polarimeter because they can be very large on the sky. In particular, if you want to study the coma or the tail, and directly if they are bright enough, or just indirectly observing the background stars, sorry, you can do some interesting science with a larger field of view polarimeter because you can have information in different sides of the comet that you are studying. So, just going to the end, there are many interesting cases, and in most cases, I'm totally not confident because it is a kind of science that I've never managed to learn. For instance, with a large field of view polarimeter, you can study even you can do polarimetry of planets, or because you can get planets can be studied even with a single target polarimeter. But if you want to study zodiacal light or other structure of the solar system that are diffuse, this is the best instrument that you can use. And I can mention planetary nebulae. They are large in the sky. So again, at least the nearby objects, but actually they are the only objects that can be observed in polarimetric mode by a 2.6 meter telescope. Any object that is extended, stars with disks and so on, and many other topics that can be of interest of a polarimeter, in particular with a large field of view, although not necessarily only. I'm not saying that we do not want to observe single targets, but this is just this would not be the best use of an instrument of this category. So let's go to the last point. Some of you are expert polarimetrists, and the very first moment I mentioned a Polaroid filter, you have probably thought that this is not able to provide very accurate measurements, in particular on a large field of view, and this is correct. However, having a large field of view means that you are observing, in any case, essentially for any field of view, hundreds of bright enough stars. And again, if you have already information about these fields, and you can get them with other previous observations or something like that, or for instance, observing targets with very low extinction, so where the stars are truly unpolarized, you have an amazing way to calibrate very accurately your field of view, correcting for instrumental polarization and for most of the artifacts introduced by Polaroid filters. And once you have calibrated your instruments, you have the possibility to do that for each field of view you're observing, any of them. Because you know already the instrumental polarization map and so on, and using the stars in the field of view, you can correct the instrumental polarization of the specific observation, and simulations that we are carrying out by Franz, Nick, and us in Milano show that essentially it is possible to get the usual floor of 0.1% polarimetric accuracy for targets that are fairly bright. I mean, I'm referring to a 2.6 meter telescope with a magnitude of around 16 or so. It could be even a bit better than that. Of course, if the polarization degree is higher, we can go much deeper as usual. So, as you can guess, there is a science team, and we are preparing a white paper. This is a bit peculiar because usually you prepare a white paper for a future instrument when you are looking for partners and eventually money. This is not the case because we already have had our financial support, but still, I think it is useful to try to define some of the most important science cases. There is a core team composed by Pietro, the PI, myself, Fabio Rigamonti, Gianluca Castigliani, two younger researchers, very clever, and Elena Pian, that you probably know very well. She is involved in AGN studies since ever. And there are, of course, several scientists that are already working for this white paper, and we plan to deliver it in sometime in 2025, maybe summer, I don't know exactly, I cannot say. If you want to be part of this enterprise, please do write to me or to us, propose your idea, and we see if it fits in the general scenario or to which extent, and so on. Unfortunately, I cannot tell you yet. I mentioned that this is a telescope thought to work almost simultaneously with the CTA, and a given percentage of time will be devoted to co-pointing almost to observe simultaneously CTA targets. These fields can be of interest for some science case independently of the object at the center. But in any case, I cannot say now yet which percentage of time, because we are still negotiating with the INAF and the CTA consortium this amount of time. It cannot be, of course, 100%. In addition, the survey telescope will still be busy in carrying out service because the science cases are not are still alive. There are follow-up observations of the surveys carried out in the last 10 years, and still a 1 square degree 2.6 meter telescope can do a lot of precious job. So I cannot actually say how much time will be devoted to polarimetry. I can only say for sure that we are going to follow a very flexible strategy. So target of opportunities, even very rapid, will be available and allowed anytime, independently of the target that we are observing. Exactly what happens at ISO. And I think this is all. You know, often when you present a new instrument, typically the time scale is 5 years, 10 years, or something like that before having the possibility to do science. In this case, we have to wait less than 2 years, 2 years. And if you are involved in polarimetry, I think that you also can appreciate how this peculiar polarimeter, a large field of view polarimeter, can open new observing windows. And I think it'll be exciting to do science with these instruments. If there are questions, I will try to reply as in order to clarify whatever I didn't explain well or so. Thank you a lot again for having followed me.
Thank you very much, Stefano. Very interesting project and talk. I'm sure there are many people here, also in the audience, interested in this wide field polarimetry. But
some of you is probably already partly involved in the project, actually, so you know already.
Exactly. Any question?
I was very clear.
Apparently.
Because
I have a bit of a technical question, but I don't know if that's it's more of the, you know, vignetting on the telescope. Is there any expectation how that would affect really the polarization? Like, do you expect to get the full square degree by square degree, or yeah,
so yes,
shrink somehow?
No, you're right. It is a very pertinent question. We, at present, at least, we expect to have the whole field of view, but simulations are promising. But you know, simulations are you decide what you put inside. There are still doubts about the border of the field of view, but the idea is to have polarimetric capabilities calibrated, well calibrated in the world field of view. This is the goal, at least. We will know soon as we will have the instruments observing the real sky, of course. Yeah, there will be a decrease of performances going through the border, but this can also be calibrated. The idea there is also the idea, I mentioned it, I think, to deliver a full operational pipeline for reduction and analysis. So you just have the numbers eventually, Q and U typically, and the errors.
Sorry, I was muted. Nikos, do you have a question?
Yeah. Thank you, Stefano, for the talk.
Sorry, I was thinking to have a reply to your question. Anyway, it's okay. Sorry, please, Nikos, go on. Nikos?
He disconnected. He has a problem,
Oh.
but he's trying to connect back.
Okay, no problem.
The equation is when the instrument is gonna be up, and if there is gonna be time from proposal.
Yeah. We think commissioning will be in the second half of 2026. We are confident that before the end of 2026, the telescope will be offered to the general community. And the access well, there will be a GTO, of course, but the polarimetric mode will be available to the general community, exactly as you can have access to the Galileo telescope at the Canary Island, with proposals that will be judged by a TAC and so on. There are a few technical limitations, not technical. I think since the telescope is a national telescope, it often happens that the PI needs to be Italian, or at least you have at least 50% of the QI from Italy. I don't remember exactly these rules. They are common with any national telescope. But if you can form a consortium, a team, I mean, of scientists interested in something, you can definitely have access to the telescope on a competitive base without any reference to the nationality. Let's say the main nationality of the team, let's say. This is the idea.
Okay.
Like the TNG.
Yeah.
The TNG, there are foreigner scientists working with it.
Yeah, true. Actually, through Opticon, you can in time.
Yeah, exactly. Regarding Opticon or this kind of organizations, I cannot say because it is well beyond my pay grade, let's say, to organize these things. It's something that it is up to INAF, and these are things that we are discussing these days, exactly to decide which is the where this telescope will be framed. I mean, Opticon or not Opticon, or other kind of structures, or just a telescope independently of any other larger organization. I don't know yet, but definitely will be open to proposals from abroad without, apart from what I mentioned, limitations.
Mm-hmm. Thank you very much.
You're welcome.
I don't see any other hand here, so I think we can thank you one more time then for your time.
Oh, I am the one who thank you. You know what people say when you invite them for a seminar. Next time they are on the island. Of course, I'm kidding you. Of course, it's fine to have this kind of modality. Okay, see you next time.
See you
sometime. Bye bye.
Thanks. See you, everyone.
Thank you. Bye bye.